I have two problems. The first one is that I got this electric drum set for Christmas because I wanted to learn how to play the drums, but I never actually got around to learning, and now every time I look at it, it makes me feel guilty. And the second problem is global warming. Now, I think I have a solution where I could fix both of these problems. I want to take a drum and make it so that it can generate electricity. That way, I'll be incentivized to learn the drums, and I'll have solved global warming as like a fun bonus perk. Let's get started. So this is called a piezo, and essentially when it vibrates, it generates electricity. Now this is really useful to us because it means that I can stick this thing on the top of a drum, and when I play it, it should generate electricity for us. And I think my goal here is gonna be to use that generated electricity to charge a phone. Seems simple enough. Now this is where we run into our first problem, which is that we don't actually have a drum to use. I mean, I could use my electric drums, but those use electricity, and that's the opposite of what we're trying to make the electricity with the. So I need to get an acoustic drum. Luckily, I know a guy.
Hi, Will.
How's it going? I have a question. Can I have a drum?
Which one?
Just like a drum.
I mean, do you want one like?
Are you ready to see the drums I got? I would have done the ch, but I don't have a cymbal. Okay, so these are the two drums I have. This one is known as a snare drum, and this one is called a tom. Toms generally have a lower tone, but more resonance, right? Snares usually have a higher tone and they have that like tsh, but they don't have very much resonance. Okay, so this right here is gonna read basically the output of the piezo. So when I tap this, you'll see that there's a big spike in voltage. My goal basically is to attach this to this drum, and that way when I play the drum, it'll generate electricity for me. Also, here we have the snare drum and the tom drum, and we're gonna play a game. It's time to play. Which drum will make more electricity? Will it be the snare drum with its higher frequency and lower resonance? Let's hear it now. Or will it be the tom drum with its lower frequency and its higher resonance? Play it. All right, make your guesses in the comments below or in your head. Either way is fine, is a-okay with me. Okay, I'm gonna tape this down. Let's see with the snare drum. All right, looks like we got like a peak of 7 volts. That's our number for the snare drum. Now let's try the tom. We got, oh geez. Okay, we're like approaching 15, let's see. Yeah, 15.9. So the tom seems to generate a little bit more current. So if you said tom, you're right. Basically, if I take the amount of voltage created by this solenoid under a load, which is the resistor, I'll be able to see how much amperage is going through that resistor and thus figure out how much power is being produced. Whoa, what does all of that actually mean? Don't worry, Will, I can explain. Also, I like your shirt. Oh. Thanks. I actually got it from the store. Okay, so we know how much voltage the piezo can generate, around 15 volts with the current setup. But that's not actually useful information until we know how much power it can generate. Because right now, the electricity that we're generating with the piezo isn't really doing anything, so the number that we have is kind of meaningless. What we need to do is put the power generated by the piezo under a load, aka a resistor. So this little blue resistor on our breadboard is essentially acting as our phone. It's how I'm gonna test how much power comes out of the thing. Now, I did some research to figure out how much power a phone needs to charge, and obviously I did that before this because I'm a responsible video creator and I plan things ahead. Okay, a phone needs generally about 5 watts of power, so as long as this thing can produce 5 watts of power, we're golden. So let's see how much voltage this generates under a load. Still nothing. Okay, yeah, you've got that little knob there, 0.17 volts. So you'll notice that the amount of voltage generated now is lower. That's because it's under a load. And we're using some fancy math, Ohm's law and the power equation, to determine how much power I'm actually able to generate with one of these piezos. Wait, let me see, 0.00018 watts, which is definitely not enough. I have a solution, obviously, I just haven't thought of it yet. Okay, so this setup does not generate enough electricity for me to charge my phone. But that's fine. That's fine. I took a night to think about it, cried myself to sleep, and I came up with 3 solutions. You ready? Solution number 1. So piezos are made up of 2 little discs with what's called a piezoelectric material in the middle. And when that material gets squished by the 2 little discs, it generates electricity. So it's generating electricity when I just have the disc on the drum because it shakes and that material is squished a little bit as it moves up and down. If I add a little bit of weight to this top disc, when I'm playing the drum, because that weight has inertia, it pushes more force on the material in the middle. So I'm able to generate about 2 to 3 times more energy that way, which is good. Solution 2. So I actually have more than 1 piezo. In fact, not to brag, but I have 10. And so I'll be able to put all of them on the drum and definitely generate a lot more energy that way. Solution number 3. Okay, so I'll be honest, we're like generating 100 times less energy than we need right now. So even with all of these solutions, it's still not gonna be enough to continuously charge my phone. So I'm gonna charge something that then charges my phone. Let me explain. Think of electricity as water, and I need about a river's worth of water to charge my phone. Well, I can only produce about a stream's worth of water. I know, pathetic. So what I need to do is I need to store all of the water from my stream using like a dam, sorry. What I do is I store this water over time until I have enough water to release the dam, sorry, thus creating a river to charge my phone for albeit a short amount of time. So the first thing to do was to buy these bolts with Kevin's help. Thanks, Kevin.
You're welcome.
And to glue those on. And now I can keep working on the circuitry. Okay, so I've changed up our circuit a little bit. Now between our load and our piezo, I've added what's called a rectifier, and editing Will is gonna explain that right now. Okay, it's time for a speed explanation. Okay, so this is a capacitor. It's essentially our dam, and it's basically a battery. It's what's gonna charge up and let go of all of our electricity. Now, there's 2 types of current. Alternating current, where all of the electrons are going like this, and direct current, where all of the electrons are going like this. Now, I can only charge this capacitor with direct current, but the piezo can only output alternating current. So I need to take the piezo's alternating current and I need to use these diodes arranged in this specific way to turn the alternating current into direct current so that I can charge the capacitor. Cool? Cool. Of course, it'd be a pain to wire up all of these diodes, so I bought these, which are basically just these diodes, but in a smaller package. I've replaced the resistor with a capacitor. Okay, so that's actually gonna store up our energy as opposed to using it. So to see how much energy we've stored, you can look at this graph. And now I can take this little LED, which for now represents our phone that we're gonna charge. You can put it right here. Oh, you see that? For a very brief moment, it lights up. So that's from energy that I just generated. Nice, we've got all 3 solutions. Now it's time to put them together using 6 piezos for now. I now have all of the piezos hooked up onto the same board, and I'm gonna see how much time it takes to get to 5 volts. But look at all of the loose wires coming out of this breadboard. It's so ugly. And as soon as I start drumming, they're gonna come out. My thing's not gonna work anymore. Now this is fine while I'm prototyping because I just need to see what works. But later on, I'm gonna need to use what's called a PCB. A PCB is basically just a board that takes a bunch of electronic components and puts them together in a more soldered, permanent way for my final product. But how am I gonna get a PCB for my project? Hey guys, it's me, PDBWAYYYY. I lost my old glasses. I'm here to tell you about PCBWAYYYY. PCBWAYYYY is your one-stop shop for all of your PCB manufacturing, CNC machining, and 3D printing needs. Now I know what you're thinking, Will, is probably so hard to use. No, it's not, stupid. You just put your files in the PCB website and you get your PCB, CNC manufactured part, or 3D print right to your door. It's so easy. I've used them 3 times before and each time my product has been great. They manufacture it quickly and it works perfect. And I'm actually gonna use their PCB service later on for this project. And now we can see how long it takes to charge the capacitor to 5 volts using just drums. So it slowed down a lot, but we're now at 5 volts. So this is actually a huge problem. For my phone to even register the charge, I'll need to give it at least like 9 volts. And yeah, I charged the capacitor up to 5 volts in like 20 seconds, but you might have noticed that charging it from 0 to 1 volts took 2 seconds, and charging it from 4 to 5 volts took like 10 seconds. That means it's gonna take exponentially longer to charge the capacitor from 5 to 6 volts, 6 to 7, 7 to 8, and 8 to 9. Not to mention the fact that capacitors leak leak voltage over time. They lose a little bit of their charge, meaning it's gonna be very difficult, if not impossible, to charge a capacitor up to 9 volts using my current setup. And this is all compiled with the fact that I'm gonna be using more than one capacitor, just so that I have more power storage. So I guess I'm wondering if there's a way that I can wire these things to get more voltage out of them. Yeah, I don't know. Okay, so if you're not into the whole learning thing, that's too bad. Pay attention. All right, so as a reminder, it takes longer to charge the capacitor from like 4 to 5 volts than it does 0 to 1 volts. We've talked about this. Therefore, it'll be a more efficient system if I can charge a bunch of capacitors to some low voltage, like 3. That should be pretty easy, and then put them together in another way that will add their voltages together to charge the phone. Let me explain. So right now, the capacitors are wired in parallel, where their leads all share a wire. It looks like this. If you need a way to picture it, you can think of those ropes that kids hold on to in line. They're all sharing one wire. Now, this wiring is ideal for charging them because they all share a voltage and it maximizes the amount of voltage that each capacitor is charged to. But there's actually another way to wire them together, and that's in series. It looks like this, where each capacitor leads to the next capacitor, and wiring them like this adds their voltage together, allowing us to get more voltage out of the capacitors. And if you need a way to think about that, you can think of, the attempt to unify the nation against hunger and homelessness in 1986's Hands Across America. Am I reaching? Anyways, wiring capacitors in parallel is optimal for charging them, but wiring them in series is optimal for using them to charge the phone. So here's my current plan. Charge the capacitors in parallel, then rewire them into series to charge the phone. Now, I already tested this, and after some trial and error, it actually worked. Oh, okay. Granted, it only charged the phone for like a second, but the phone registered that it was charging. And at this point, if we can get the phone to register that it's charging, if we can get it to go ding, then I call that a win. Now it's time to design the PCB. All right, chat, so here's the schematic that we have so far. We've got the piezos over here on the left. There's 9 of them. Each of them are gonna feed into their own rectifier. And these rectifiers feed into these capacitor groups, okay? Now, these capacitor groups are essentially just groups of 3 capacitors that act as one bigger capacitor. Now, this switch manages them. This is very important, okay? So pay attention. Pay attention. This switch actually manages the wiring of these capacitor groups. So when they're switched this way, that's wiring these 3 groups in series, which is optimal for discharging the capacitors into the phone. And when they're flipped the other way, it's optimal for charging up the capacitors because these are wired in parallel. And then obviously this is the USB charger here and a little button that activates it. Now it's time to bring this over into the physical PCB to put this all together. This is me working in real time. My hands actually move that fast. Let me check some of the comments. Please read out loud. I see. I'm not gonna do that. Okay, you know that. Not again. Hey, Fuzzy Wuzzy 68, thanks for the tier 1 sub. Really means a lot, man. Oh hey, that bit went on long enough for the PCBs to get here. Let's open them up. All right, so here's the PCB we got. This is the spot for the capacitors, and then the rectifiers right here. The switch will fit in here, and then this is where the phone charger goes. So yeah, let's put it together. Okay, it's time to actually test this thing. I'm a little nervous. Are you nervous? I'm a little nervous. We got a 2-camera setup here, not to brag, so you can see I can switch between the cameras really fast. I've got the oscilloscope here measuring the current. I want to note that this is not providing any current to the circuit, just in case there was confusion there. All the electricity we're using to charge these up is just coming from the drums. They're not coming from here. And then also, I just wanna note, if you see any like issues in my drum technique while I'm doing this, please tell me in the comments below, because I've talked about this before, but I love engagement, okay? In fact, even if you don't know anything about drumming, just tell me that I'm doing it wrong for some reason and make something up. So yeah, if you see any issues in my technique, or even if you don't, please correct me. We're gonna put it in charge mode here. So this switch switches between charge mode and drum mode, right? So this is putting all the capacitors in parallel. flip this, and then, okay, did not register. Not enough voltage. Okay, we are so close to getting this phone to charge. I can taste it. It tastes like a phone. But we're still not generating enough electricity to charge it, even for just a second. So I have one final solution up my sleeve, though it requires a lot of knowledge about electrical engineering and circuit design. So I need you to really pay attention so that you can fully understand. I'm gonna drum harder. I'm gonna hit the drum harder so that I can generate more voltage. That's the plan at this point. I think I need to get to at least 3 volts on here. So I'm just gonna keep going until I get there, I guess. All right, okay, I gotta do this fast. I'm gonna click here to put it in charge mode, and I'm gonna hold that down. It did it, it did it. We have the charging thing. It registered a charge. I have officially used solely drum power to technically charge a phone a little bit. I'm over the moon. I don't know if it's joy or just relief that I'm feeling right now. But either way, what a wonderful feeling. It only took like 27 minutes of drumming to charge the phone for about a quarter second. I think this is groundbreaking stuff. This is such an innovation. I think this is the only way that people are gonna charge their phones now. So did we solve global warming? I would say it's up for debate, but did I drum a lot? Yeah, I definitely drummed a lot. Anyways, I want to thank you guys so much for 10,000 subscribers. That's kind of crazy. And as a cool challenge, here's a video of me drinking 10,000 microliters of water. I haven't actually recorded it yet, so I hope I end up doing that. Also, thank you so much to my patrons who helped me buy things that cost money. I did just get to college, so making these videos might take a little bit longer, or they might not. I have no idea. But anyways, thanks so much for watching, and goodbye.
Makes sense going back. Do debit, cash, or
Make a
gift card?
return. Yeah. Thank you. You too.